So let's have a look at calculus and specifically quadratic function, and we're going to be considering the maximum place or the minimum place. Both of them have the same process of finding. Let's see, the profit of the company for the second year can be modeled by the function. And we are given a function here. It is a quadratic function because we have x to the power of 2. And they are saying that q of x is the profit. So this here, that's my profit equal. And the profit is given in millions of euro, and X is the number of phones in 10 of 1,000 it produces in the second year. So those two X's here represent number of phones. So again, we have to understand that my X here, that will be number of phones, and this Y here will be profit, and really that profit, that is number of euro we're going to have. Okay, so what do we need to do? First, we have to find, and this is it, what means what? A derivative of this function q, and hence, meaning with this knowledge, find the value of x. So one thing, find the derivative. Two, find the value of x. What kind of value of x? That will give me the maximum value of this function. So we are looking for the maximum value. When we have to do maximum or minimum, doesn't matter, the process will be the same. And then I already brought the second part, because then in the second part is saying hence. So once we have what? This value of x, we're going to find what? The value of y, the maximum value of y. So basically, the graph of this function is going to be a parable, is going to be going up and down like that. And this is the place we are looking for. That's the maximum place. So first I need to find x. And once I have x, then in the second part, they want me to find y. So the full coordinates of that place. And when we have to find, like I'm saying, maximum or minimum, what do we do? First of all, we create derivative of a given function, and that's our first part. Second thing, we equal the derivative we created to 0. The next part, we find the value of x, and that's what we do in here. And then usually when we are looking for the full maximum place, like here, and that will be part 2, this is where we take our, oops, do you want to write that? This is when we take x back to the original function, not the derivative, back to our function here, sub it in, and therefore we find the value of y, and that part, that fourth part, will be here for the second part. Okay. So how do we create a derivative? Now, don't forget, each element is separate. So I'm just going to remove that. How do I know? How do I identify each element? By plus and minus. So that's one element, that's the second one, and that's the third one. So let's consider each one of them. I'm just going to list them here. Minus 1.5x to the power of 2. Plus 9.6x, and then minus 3.5. So the two of them, this one and this one, straight away we know that when there is no x beside the number, in the process of differentiation, meaning creating that derivative, that goes to 0. When I have x with no power, or power of 1, because that's what we have, derivative of that item will be the number that stands beside x, in our case 9.6, and only in my first part that I'm going to be applying formula. What kind of formula? If we go to our table and calculus, page, let's see, page 25, is only that first formula we are concerned with. So that means when x is taken to the power of n, then that n goes in front of x, and that power minus 1. What happens with the number that stands here in front of x? That number will cross over. So in our case, applying that minus 1.5 will cross over, multiply, then n is what? The power, my power is 2, multiply by x, and then the power, which is 2, minus 1. So that means we put in the calculator minus 1.5 multiplied by 2, that will be minus 3, and then x2 minus 1 will be 1, so we can leave it without power. So therefore, now let's put together our derivatives. So that will be minus 3x, the second element plus 9.6, and then 0 we can ignore because that means nothing. So we've done the first part, created derivative. Now we equal that derivative to 0. So that's what it is. We replace that our y with 0. Now we have to solve it for x. So my x have to be on its own. I have a choice here. Either I move minus 3x to this side or plus 9.6 to the other side. Doesn't matter which one. Now here I would say because it's negative, let's move that to the other side. Therefore, it becomes positive. How come? Because if we move a number from one side of the equation to the other side of the equation, it changes the sign to the opposite. So negative becomes positive. 3x, we want x, not 3x, which means 3 multiplied by x. How do we get rid of multiplication? We divide, and we divide both sides of the equation because 3 divided by 3 is 1, and 1 multiplied by x is x. And we put that part in our calculator, we press equal, and we get that the value of x is 3.2. So that's really for that first part. We did find the x. Now we are going to the next one, finding the y. So we take our x that we found back to the original function. What is the original? This one here. We're going to replace x with this value and therefore find the value of y. So let's do that. So we are saying we are looking for the value of this function q when x is 3.2. So we're going to have minus 1.5 multiply instead of x 3.2, that is taken to the power of 2, plus 9.6, again multiply by the value of x, which is 3.2, and then minus 3.5. And we put that in the calculator, press equal, and we get 11.86. Now, this is a very typical in your exam. So once you see that word maximum, minimum, or any other word that means that like the greatest or the least, that's how we know, that's what we do in this type of a question.